Now let's talk about acceleration. Acceleration is the rate at which velocity changes. It's how fast your speed changes and your direction changes. So remember, speed and direction is velocity. So acceleration can occur if you change your speed, if you change direction, or if you change both. Acceleration is a vector because it includes both a magnitude, speed, and a direction. An example of acceleration is free fall. Free fall is when you're falling due to gravity. And the gravity makes you speed up. There are no other forces causing you to speed up. The acceleration due to Earth's gravity is 9.8 meters per second squared. This is a constant. This means that you will fall 9.8 meters per second faster each second. So for example, let's say you're going 0 meters per second, and then you start to fall. So let's say you're standing on the edge of a building and then you fall. So after 1 second, you will be going 9.8 meters per second. After a second, you will be going 9.8 times 2 meters per second. After 3 seconds, you'll be going 9.8 meters times 3. So you're going 9.8 meters per second faster per second. So that's 9.8 meters per second, or 9.8 meters per second squared. When you accelerate, when you have a change in velocity, you can feel it. For example, if a car speeds up, you're pushed back in your chair. You can feel the acceleration. If a car slows down, you're flung forward in your chair. You feel the deceleration or negative acceleration. When you go around a corner, you're thrown to the outside of the car. That is also acceleration because you can feel it. No, you're not changing your speed, but you are changing your direction. And as long as you can feel the change, that is acceleration of some type. If you don't feel it, then you're not accelerating. If you go a steady speed straight ahead, you don't feel like you're really moving. You might feel the bumps of the road, and that's of course a slight change in velocity, but because you're going up and down, but you have a steady speed, so you don't feel like you're going faster or slower, because you're not. This weight on a string is my accelerometer. When the accelerometer swings, it means I'm accelerating. If the accelerometer remains hanging straight down, I am not accelerating. So of course when I'm standing still, I'm not accelerating. Notice when I speed up, the accelerometer swings. Let's see that again. Also notice when I slow down, the accelerometer swings. Also, when I turn in a circle, the accelerometer swings. So if I speed up, slow down, or change directions, I'm accelerating. If I can go a steady speed, see how it hangs straight down? And then when I stop, it swings. When you make a distance-time graph, how do you show acceleration? Well, remember, if your distance-time graph has a flat line with 0 slope, you are going 0 speed. Speed is your slope. If you have 0 slope, you have 0 speed, 0 meters per second. If you have a shallow slope, you are going a steady, slow speed. If you have a steep slope, you are going a steady, fast speed. But what if you're changing your slope? What if you're changing your speed? That's what I'd like to look at now. If you begin from a stop, your slope will be 0 because there is no speed, no velocity. You're going nowhere. Then, as you go faster and faster, your velocity will increase. So your slope will increase. See how this slope is slowly increasing? Let's use the pen. You're going straight ahead with 0 slope, and then the slope gets steeper and steeper and steeper, so you're going faster and faster. Here, you have 0 speed, and it's getting steeper and steeper, so you're going faster. Isn't that weird? Well, here's what's happening. Remember, this is when you are near the detector, and this is when you are far from the detector. So you are speeding up and moving away from the detector. Then here, you are starting far away from the detector and coming back. You are going from far to near. Therefore, you are speeding up as you come back toward the detector. All right. Here is a graph of negative acceleration. You have a very steep slope, you're going fast. Then it gets less steep, you're going slower and slower and slower until you have zero speed. You come to a stop. Here, you have a very fast speed because it's steep. You're going slower and slower and slower until you come to a stop again. Once again, this is moving from far away to near. So this is toward the detector. This one is moving from near to far, so this one is moving away from the detector. But both graphs are slowing down.